Hello dear students, in this class we will discuss about continuity of a function. When we can say that the given function is continuous at a given point nothing but a specific real number. When we can say that a given function is continuous at some particular real number. Let me write what the condition that function has to satisfy. The condition is like this. A limit of f of x as x tends to a must be same as f of a. This is the condition to be satisfied by a function to say that it is continuous. Very simple condition. A limit of given function at the point, say maybe a, must be same as f of a. What is meant by f of a? Function value of a. When these two are equal, then only we are able to say that the given function is continuous at that point a. Now, suppose if the limit of the function is different from value of the function, they are not coinciding, then we say that function is not continuous at the point A, or we say function is discontinuous at the point A. Now, what are the cases where we say that the function is discontinuous? To say that function is continuous, limiting value of the function must be same as value of the function. Now, in order to say that function is discontinuous, different reasons, different cases arises. One case, the value of the function may not exist, because the limiting value of the function must be equal to value of the function at the same point. If the function value itself does not exist, then definitely that function is discontinuous. This is one kind of discontinuity. Now, suppose if function value exists, we cannot say that it is continuous. We have to check what is the limiting value of the function. If the limiting value of the function does not exist, then also I have to say that function is discontinuous. Even though function value exists, the limiting value does not exist, then we say that function is discontinuous. Or if the limiting value of the function exists, function value does not exist, then also I have to say that function is discontinuous. The third case is function value exists, limiting value of the function also exists. Function value exists means what? It is a finite real number. Function value exists, limiting value of the function also exists, but they are different, they are not going to be coincide. Then this is the third reason where we say that function is not continuous. That point where function fails to be continuous, that point is called as point of discontinuity. I hope you followed the definition. Whenever a function is given and a point is given, how to check a given function is continuous or not? Find the limiting value of the function at that point, find the value of the function at that point, then check whether they are equal or not. If they are equal, you write the conclusion the function is continuous. If they are not coinciding, then you write it is discontinuous. Moreover, still elaborate. When we say that limit of the function exists, so this we already discussed in first PUC limit chapter. To say that limiting value of the function exists, both the left hand limit, right hand limit must exist and they must coincide. Then only we say that the limiting value of the function exists. Now if we consider that case, here we can say if left hand limit, right hand limit of the function at the point A and the function value at the point A, all these three must exist and they must be equal, then only we say that function is continuous. So we can write like this also. So LHL must be equal to RHL must be equal to value of the function that point, then we say that function is continuous. And now let me take some examples here to check whether those functions are continuous at the given point or not. Here I took f of x equal to 1 if x less than or equal to 0, f of x equal to 2 if x greater than 0. At what point I have to test the continuity? 0. 0 is the real number. There I written a value is 0. At this point, I have to check whether this function is continuous or not. What is the procedure? Find the function value, find the limiting value, check whether they are equal or not. Now let me go for finding the limiting value. How to find the limiting value of the function? If you observe the definition here, whenever the value of x less than or equal to 0, the definition of the function says it is 1. I will take it as 1. Whenever x is strictly greater than 0, then I have to take 2. Means at the point 0, left side of 0, right side of 0, definition of the function changes. So here I have to for evaluating limit with the help of left hand limit, right hand limit. Now let me write first left hand limit. The limit as x tends to 0 minus. Yes, what is the meaning of this? X approaches to 0 from left side of 0. That is, x is becoming very close to 0, it is approaching to 0 through the values less than 0, nothing but from left side of 0 of f of x. Limit as x tends to 0 from left side. What is the definition of the function? According to it, whenever x is less than 0, x approaches to 0 from left side of 0 means definitely it may be minus 0.00001, like that. It is very close to 0. Now, in that case, the definition of the function it says it is 1. What is the limiting value of 1 as x approaches to 0? We discussed the property of limit. It says a limit of a constant as x approaches to some other constant a. As x approaches to a, the value of k never changes. It remains same. It is equal to k. Suppose if we take the value of k as 10 and write the limiting value of 10 as x approaches to a as 10. Suppose if we take the value of k as 2. As x approaches to 2, is there any change in the constant then? It is not going to change, never changes. It remains 10 only. Similarly, here x is approaching to 0, maybe from left side. By that 1 is not going to change, it remains same 1. So left hand limit is 1. Now right hand limit. The limit as x approaches to 0 from right side. Whenever x is approaching to 0 from right side of 0 means it is understood it may be 0.00001, slightly greater than 0. It is approaching to 0 from right side, greater than 0. Whenever x is greater than 0 means the function value I will take 2. So limit as x approaches to 0 from right side, I have to take according to the definition of x as 2. Again 2 is a constant, limit of 2 as x approaches to 0, maybe from right side, it is equal to 2. So left hand limit exists, right hand limit exists. Now check whether they are equal, not equal. So limiting value of the function does not exist. I said 3 reasons when to say that function is a discontinuous. Either limiting value does not exist. Second case, maybe function value does not exist. Third case, both limit of the function exists, function value exists, but they are not coinciding. These are the 3 cases where function fails to be continuous. Now here in this case, LHR is different from RHR, therefore limit of the function does not exist. Once the limit of the function does not exist, straight away we can conclude that this function is not continuous. Now, LHL not equal to RHL. Therefore, limit of f of x as extends to 0 does not exist. Therefore, f of x is discontinuous. Therefore, it is discontinuous at x equal to 0. There is no meaning you go for finding function value. No need to find a function value. Since the limiting value does not exist, straight away conclude that it cannot be a continuous function. Suppose LHL equal to RHL, limit exists, then go for finding function value, then compare limiting value and function value. Now, this is the mathematical way of checking whether given function is continuous or not. Now let me look at this continuity in different aspects through graph. Now let me write the graph of this function. F of x is 1 whenever x less than or equal to 0. F of x is 2 whenever x strictly greater than 0. Now let me write the graph of that. Okay. What the definition says, whenever x less than 0 or equal to 0, its value is 1. I take x equal to 0, value of y is 1. I take x as a slight less than 0, maybe here minus 1, minus 2, here plus 1. Plus 2. Now whenever x is taking the value very close to 0 but left side of 0, it is 1, minus 0.5, 1, minus 0.9, it is 1, minus 1, 1, minus 1.51, minus 2, 1. If you join all those points, you are going to get a straight line. Remember, at x equal to 0, y equal to 1. Now when I take x slightly greater than 0, maybe 0.001, what is the value of the function? 2. It comes over here. When it is 0.1, it is 2. When it is 0.5, 2. 0.9, 2. 1, 2. 1.5, 2. 2, 2. So now join all these points. Is this line, is this graph is going to intersect y-axis? No. Because whenever x equal to 0, value of the function is 1. Slightly greater than 0, it jumps to 2 straight away. So in order to indicate that, I write a knot indicating this line is not intersecting y-axis. So this is what graph of this function. F of x equal to 1 whenever x less than or equal to 0, f of x equal to 2 whenever x is greater than 0. Notice here, at 0, we are saying that function is a discontinuous. Now if you observe here, from minus infinite to 0, there is no break in the curve. A number greater than 0 to up to infinite, discontinuous at 0. Means at x equal to 0, there is a break in the curve. That is what the graphical interpretation of discontinuous means. Or the other way of understanding is, in order to say that function is continuous at 0, you should be able to draw the graph of that function around the point 0 without lifting pen from plane of the paper. Can we do that here in this case? Now I am taking the pen, drawing the graph. When it comes to 0, I have to lift my pen and start writing the graph from here. Since at the point 0, around the point 0, I have to lift my pen to draw the graph of that function. So we have to say that that function is discontinuous at that particular point. So this is what geometrical interpretation of a discontinuous or continuous. To say that function is continuous at A, without lifting your pen, you should be able to draw the graph of that function around that particular point. If you are not able to do that, then that function is discontinuous. Now you have already come across many graphs. So recall all those graphs. Now you can definitely tell whether they are continuous or discontinuous. Continuous means without any break. You can recall the sine curve. Sine curve is continuous one, no break in the curve. So it is continuous at all real points. There is no breakage in the curve. Recall tan x function. Is a tan function continuous at all real points? Yes, let me write the graph of that. This is minus pi by 2, this is plus pi by 2. This is the nature of the graph. Then if you continue here, pi by 2, 5, 3 pi by 2. Now, do you feel that this curve is continuous? No. I need to lift the pen at which points? At pi by 2. So, at pi by 2, there is a break in the curve. Therefore, this tan function is discontinuous at x equal to pi by 2. Similarly, at minus pi by 2 also, there is a break in the curve, because if you continue here, again you need to lift the pen. So, at x equal to minus pi by 2, at x equal to pi by 2, at x equal to 3 pi by 2 also. Because if you write, if you continue this 3 pi by 2, it is 2 pi, 5 pi by 2. The graph will be like this. Again at this point, I need to lift the pen to draw the graph. So there is a break in the curve. At which point? 3 pi by 2. So at 3 pi by 2 also, that function is discontinuous. So this is the simplest way of understanding the discontinuity of a function. But in the board exam, whenever they ask about check the continuity or find the point of discontinuity, you cannot write the graph and test where it is discontinuous. Instead, we have to go for using this formula. First, find limiting value function, function value. If at all they exist, check whether they are equal or not. If they are equal, then only you say that the function is continuous. Otherwise, it is discontinuous at the point A, and that point A is called as a point of discontinuity. With that context here, pi by 2 is a point of discontinuity for a tan function. 3 pi by 2 is another point of discontinuity of the function, etc. Okay. Now let me take another example. It is f of x equal to 1 whenever x is different from 0. F of x equal to 2 whenever x is 0. Required to find the continuity limit of the function at x equal to 0. Now let me write the graph of this function first. F of x is 1 whenever x is different from 0. Different from 0 means other than 0. It is 0.001, it is equal to 1. It is a minus 0.001, it is equal to 1. At all points other than 0, the function value is 1. This is the line y equal to 1. So now, when x equal to 0, the function value is 2. Here it is. Here it is the function value at 0. What about here? There is a gap because it is not continuous now. So, is it possible to draw the graph without lifting the pen? Definitely not. Where do we need to lift the pen? At the point 0. Therefore, there is a break in the curve at x equal to 0. Around the point 0, I cannot draw the graph continuously. I have to lift my pen. So, therefore, it is a discontinuous at x equal to 0. By graph, it is possible to tell. Now, let me go for using the definition. Limit of the function must be same as the value of the function. Let us check. Let me go for finding a limit of the function. LHL, there is a limit as x tends to 0 from left side. Here, no need to go for finding left hand limit, right hand limit, because whenever they say x approaches to 0 means it is either from left side or from right side. Means x is different from 0. If it is approaching to 0 from right side, greater than 0, slightly greater than 0. If x is approaching to 0 from left side, slightly less than 0, means it is a negative value. Means in both the cases they are different from 0. Whenever they are different from 0, function is defined uniquely, that is equal to 1. So straight away I can write a limit as x tends to 0 of the function. X approaches to 0 means it is different from 0. Remember, it is not equal to 0. So whenever x is different from 0, the function should be taken as 1. A limit of 1 is equal to 1. Now find the function value at 0. We determine the limiting value. Find out function value f of 0. Whenever x equal to 0, according to the definition, how much it is? 2. So, limiting value of the function exists, means it is finite, real number is 1. Function value also exists, and it is equal to 2. Both exist. Limiting value exists, function value exists. Are they equal? No. So, what is the conclusion? It is a discontinuous. That we already checked through graph. So, here, since a limit of f of x as x approaches to 0 not equal to f of 0, that is function value at 0. F of x is discontinuous. I hope you are following the procedure. To test whether the function is continuous at a given point, what is the procedure? Find the limiting value of the function. To find the limiting value of the function, in some examples we need to go for finding LHL RHL, like in the previous example. But in this example, straight away we can find out limiting value of the function. After finding limiting value of the function, go for finding function value. If both exist, check whether they coincide or not. If they are not coinciding, like here, you say that function is a discontinuous at that point. Now, the other question, f of x equal to 2x plus 3 at x equal to 1. Very simple function they are given. F of x equal to 2x plus 3. At which point we have to find out? At x equal to 1. Now let me write the graph of this function. Let me take some 2 points. When x is 0, y is 3, 0, 3 is 1 point. I take x equal to minus 1, y equal to 1. 2 points I am able to get. As this is linear function, it must be a straight line. This is what nature of the graph of f of x equal to 2x plus 3. Now, by looking at the graph, can we say that is this function continuous at x equal to 1 now? What to do? We need to check around the point x equal to 1. Here it is x equal to 1. Around the point x equal to 1, is there any break in the curve? No break, because we are not lifting the pen to draw the graph of the function around the point x equal to 1. So this itself is the indication that function is continuous at x equal to 1. Now let me check. First I will go for finding function. That is, limiting value of the function. Limit of f of x as x tends to 1. What is the definition of the function? There is no conflict here. Either x approaches to 1 from right side or from left side. In both the cases, it is 2x plus 3 only. That is equal to 2 into 1 plus 3. That is equal to 5. Now find function value of 1. Wherever x is there in the given function, substitute x equal to 1. It is 2 into 1 plus 3. That is equal to 5. Clearly, the limit of f of x as x approaches to 1 is the same as f of 1. Therefore, f of x is continuous at x equal to 1. So, this is the procedure of testing whether function is continuous at a given point or not. We determine the limiting value of the function. We determine the function value of the function. Both exist. Not only they exist, they coincide. Therefore, the conclusion is function is continuous at that point. I hope you understood. Very simple thing. I hope you remember the procedure of evaluating the limit of a function. What is the procedure of evaluating the limiting value of a function? You simply find out function value. If the function value exists, that itself is taken as the limiting value of the function at that point. If the function value does not exist, maybe it takes indeterminate form, 0 by 0, infinite by infinite, infinity to the power of infinity, something like this. Whenever it takes indeterminate form, we have to use some techniques to remove those indeterminate forms. Then you evaluate the limit of the function. That is the procedure. I hope you remember. Next, let me take another question. F of x equal to x square at x equal to 0. F of x is x square. At which point I have to test the continuity? 0. Now, through graph, let me find out whether it is continuous at 0 or not. Again, this term is familiar to you, f of x equal to x square. Let me write the graph of that. It is a parallel opening upward. This is what the nature of the curve f of x equal to x square. At which point I have to find? At 0. Is there any situation where to draw the graph of f of x equal to x square around the point x equal to 0, is there any necessity of lifting the pen? No. Clearly it is continuous. So, without lifting the pen around the point 0, I can draw the graph of that function. So therefore, here it is a continuous one. Let me verify it mathematically. First, I have to go for finding limit of the function. Limit of f of x as x tends to 0. x equal to 0, substitute x equal to 0, 0 square, nothing but it is 0. I want function value, that is 0 square, that is equal to 0. So here also, the limit of f of x as x approaches to 0 is the same as function value at 0. Therefore, f of x is continuous at x equal to 0. This function is also continuous. Now let me take another one. F of x equal to mod x at x equal to 0. Modulus function is also familiar to you. You already drawn the graph of that. Yes, what is the nature of modulus function? It is in the shape of V. This is what the modulus function. Yes, I hope now it is clear. You will be able to decide whether it is continuous at the point 0 or not. Around the point 0, is there any necessity of lifting the pen while drawing the graph? No need, because continuously it is flowing like this. So therefore, it must be a continuous function at the point 0. Now let me check through the definition. First I have to go for finding the limit of the function. I hope you remember the definition of modulus of x is minus x whenever x less than 0, and the modulus of x is plus x whenever x greater than or equal to 0. Now I have to go for finding LHL. The limit as x tends to 0 from left side. Whenever x is approaching to 0 from left side means the value of x is slightly less than 0, means they are negative. Whenever negative, I have to consider minus x as a function. Now substitute 0 minus 0 I get, it is 0. Now RHL. The limit as x tends to 0 from right side. Whenever x is approaching to 0 from right side means slightly the value of x is greater than 0. Whenever x is slightly greater than 0, they are positive values. So whenever x is greater than 0, the function definition says it is x. Now it is equal to 0. So LHL is same as RHL. Therefore, a limit of f of x as x tends to 0 is equal to 0. We are able to find the limit of the function, and we observe that the limit of the function is 0. Now, find function value at 0, f of 0. That is the modulus of 0, that is equal to 0. Or whenever x is greater than 0 or equal to 0, it is x. Substitute x equal to 0, you are going to get 0. So now, the function value is 0, the limiting value is 0, both are coinciding. Limit exists, function value exists, moreover they are coinciding, therefore it must be a continuous function. So since a limit of f of x as x tends to 0 is equal to f of 0, given function is continuous at x equal to 0. I hope you are following the procedure of testing the given function is continuous or not. Finally, one more example here. F of x is x cube plus 3 if x is different from 0, and f of x is 1 if x equal to 0. At which point I have to test function is continuous or not? At x equal to 0. Okay, now, first we will find limit of the function. Limit of f of x as x tends to 0. The limit as x tends to 0. Which function I have to take? X tends to 0 means x is very close to 0. Means it is not exactly equal to 0. It is different from 0. Whenever it is different from 0, I have to take x cube plus 3. So now Now I have to find the function value at 0. Whenever x equal to 0, what is the function they have given? 1. So f of 0 is 1. Now, limiting value of the function exists. Value of the function also exists. Both exist. Limiting value, function value. But they are not coinciding. Since the limit of f of x as x tends to 0 is not equal to f of 0. F of x is discontinuous. That is equal to 0. What about graph of this function? I have drawn the graph of x cube. F of x equal to x cube. The graph of f of x equal to x cube is what? This is what? The nature of f of x equal to x cube. Now it is x cube plus 3. Plus 3 is added to each x cube. So 1, 2, 3. Now the graph will be like this. This is x cube plus 3. So whenever x is different from 0, I have to take x cube plus 3. But when x equal to 0, it is 1. At x equal to 0, it is 1. It is not equal to 3. Because f of 0 will give us what? F of 0 means 0 cube plus 3. That is not the value. Whenever x equal to 0, I have to take it as 1. That is what they are saying. Means there is a break in the curve at this point. Whenever x is slightly less than 0, it is approaching to 3. Whenever x is slightly greater than 0, it is approaching to 3. That is what this limiting value of the function again. Limit of f of x equal to 0, 3 means what? Whenever x is approaching to 0, either from left side or from right side, the function value is approaching to 3. It is almost 3. But exactly at x equal to 0, the given function value is 1. Now, definitely, I need to lift the pen around the point 0 because up to here it is continuous. Means in order to plot this point, I have to lift the pen because there is no continuity here. I have to plot this point, then continue here. So, therefore, there is a break in the curve at the point 0, hence it is a discontinuous function. Now we will take the function as a constant function and we will check whether this constant function is continuous or not. At what point? We will take any point. Maybe 0, maybe 1, maybe 0.1. At some real point whether this constant function is continuous or not. Let us check. For convenience, instead of taking this constant as a, suppose if I take 2, f of x is 2. Now my job is to check whether it is continuous or not. Now, let c be any real number. It is one variable. Maybe c is 1, maybe 1.1. If you take c equal to 1.1, so we are testing the continuity of the function at 1.1. If c value is 0, we are testing the continuity at c equal to 0. If c is minus 10, we are testing the continuity at minus 10. So that is how it goes. That is why I written let c be any real number. The limit of f of x as x approaches to c. Limit as x approaches to c. What f of x is 2. As this is 2 constant, wherever this x is approaching, this 2 remains 2 only. Means limit of this function at the point c is equal to 2. If you take c as 10, the limit of the function at x equal to 10 is 2. Now, what is function value at c, f of c? What is f f of 1? 2. What is f of 2? 2. What is f of 0? 2. Function value never changes because it is constant. That is why it is a constant function. So f of c is 2. So therefore, limit of f of x as x approaches to c is the same as f of c. Therefore, f of x is continuous at x equal to c. At which point it is continuous? At x equal to c. What is c? You can take any real number. If I take c as a 0, okay, the limit of f of x as x tends to 0. The limit of 2 as x approaches to 0, it is 2. f of 0, 2. Therefore, limit of f of x as x tends to 0 is same as f of 0. Therefore, f of x is continuous at x equal to 0. I want to know whether this constant function is continuous at x equal to 10 or not. So, limit of f of x as x approaches to 10. The limit of 2 as x approaches to 10. If x is approaching to 10, nothing is going to happen to 2. So, therefore, it is 2. Now, value of the function at x equal to 10, it is 2. So, therefore, limit of the function as x approaches to 10 is same as function value at x equal to 10. Therefore, f of x is continuous at x equal to 10. In this way, this constant function f of x equal to 2 is continuous at all real points. There is no point of discontinuity for this. In general, instead of 2, if I write k can be any real number. So clearly, this constant function is continuous. So here, once again, let me write by taking c. The limit of f of x as x approaches to c. The limit of k, because now f of x is k as x approaches to c is what? K. Function value of c is k. So limit of f of x as x approaches to c is the same as the function value at c. Both are k. Both are k. So therefore, f of x is continuous at x equal to c. What is c? General real number. Therefore, this constant function is continuous at all real points. Now let us understand this through graph. Write the graph of f of x equal to 2. What is the graph of f of x equal to 2? When x is 0, what is the function value? 2. When x is 0.1, it is 2. X is 0.5, 2. X is 1, 2. X is minus 0.1, 2. X is minus 1, 2. Join all those points. This is the graph of f of x equal to 2. Is there any break in the curve? It is a straight line, never ending, continuous everywhere. So therefore, remember, constant function is always continuous. Means constant function is continuous at all real points. That point you have to remember. Next, I took f of x equal to x. Can you recognize what kind of function it is called f of x equal to x? Yes, it is called an identity function. Now, can I write the graph of identity function? How it looks? Identity function. F of x equal to x, nothing but what? Y equal to x. Nothing but this is a straight line. Of course, crossing through origin. This is the line y equal to x. It is also continuous. Therefore, identity function is also continuous. Now let me write that. Now f of x equal to x. Let's see the any real number. Maybe 2, maybe 3, maybe part 1. What is the limit of f of x as x approaches to c? What is f of x? X. As x approaches to c, what happens to x? It is approaching to c. Now f of c, nothing but what? It is equal to c. Wherever x is there, replace with c. So here you get both as c. So limit of f of x as x tends to c is equal to f of c. Therefore, f of x is continuous at x equal to c. So identity function is also continuous at all the real points. Not only constant function is continuous, identity function is also continuous everywhere. It is nowhere discontinuous. At all real points it is a continuous one. Now, you have to remember the definition of continuity of a function. Till now what we did? We discussed continuity of a function at one point. In these two examples we discussed continuity at all the real points. Now, the generalizing the definition of continuity of a function. Whenever we say the function is continuous, it means that function is continuous at all real points in the domain of that function. Now here it is. A function is said to be continuous. In general, if we say continuous, not mentioning any particular point, then what it means? If it is continuous at every point in the domain of that function. I hope you remember what is the domain. Suppose if I take f of x equal to 1 by x. What is the domain of the function? All real numbers except 0. All real numbers except 0. Suppose if I write f of x equal to 1 divided by x plus 1. What is the domain of this function? Means at what points the function value exists? Nothing but domain of the function. Function value exists at all real points except at only one point, namely -1. So therefore domain of the function is on minus singleton set -1. So whenever function is said to be continuous without mentioning a point, they are not mentioning the point, simply they are saying function is continuous. It means what? It is continuous at all the points in the domain of that function. Now, with respect to this definition, we will consider the examples of continuity of the function in the next class. Thank you.